The Claude developer team just announced something small on the surface, but very important if you build serious products on top of Claude. It is a new cache analytics dashboard inside the Claude Developer Console. The original post is only a single screenshot, not a live walkthrough, so this video is a source-grounded explainer built from that screenshot, the official prompt caching docs, the pricing docs, and Anthropic's own cookbook. What matters here is not a flashy UI reveal. It is the fact that Anthropic is finally giving teams a clearer way to see whether prompt caching is actually saving latency, saving money, and paying back the extra write cost over time. Start with the screenshot itself. The page headline reads Prompt Caching Dashboard, and the main dashboard view is labeled Caching. In the top right, you can filter by workspace, by model, and by time range. In this example, the model filter is set to Claude Opus 4.6 and the date range is the last 7 days. The hero metric is cache read ratio, shown here at 76.5%, with a green lift versus the prior week. Below that is a cache usage breakdown table. It shows input tokens, composition, read ratio, and write amortization. The composition bar separates uncached traffic, 5-minute cache writes, 1-hour cache writes, and cache reads. Then at the bottom, there is a cache read ratio chart over time with 1 hour, 3 hour, 6 hour, and 24-hour windows. So even from one screenshot, Anthropic is telling you exactly what this feature is for. It is a visibility layer for how well your cached prefixes are performing in production. To understand why this dashboard matters, you have to look at the prompt caching docs. Anthropic defines prompt caching as a way to resume from specific prefixes in your prompts, which cuts processing time and cost when large parts of the request stay the same. The docs describe 2 ways to turn it on. The first is automatic caching, where you add a single cache_control field at the top level of the request and let the system manage the breakpoint for you. Anthropic explicitly presents this as the simplest way to start. The second path is explicit cache breakpoints, where you place cache_control directly on specific content blocks for more control. The docs also make the default time window clear. Standard cache entries live for 5 minutes, and Anthropic refreshes that cache for no extra cost when it gets used again. If 5 minutes is too short, there is also a 1-hour cache option at additional cost. So the dashboard is not a standalone feature. It is the observability layer for a caching system Anthropic already expects teams to use in long prompts, repetitive tasks, and multi-turn conversations. The most useful part of the docs is the section called Tracking Cache Performance, because it explains exactly how the numbers behind this dashboard are computed. Anthropic says you should monitor 3 usage fields in the API response. First, cache_creation_input_tokens, which counts tokens written into a new cache entry. Second, cache_read_input_tokens, which counts tokens pulled from an existing cache. Third, input_tokens, which counts the uncached tokens that come after the final cache breakpoint. The docs warn that input_tokens is not your full prompt size. The total is cache_read_input_tokens plus cache_creation_input_tokens plus input_tokens. That distinction matters because a team can look at a tiny uncached tail and mistakenly think a request is small, when in reality most of the workload is being served from cache. Now the dashboard screenshot makes more sense. The read ratio card, the breakdown bar, and the time series graph are all trying to summarize those low-level usage fields into something an engineering team can scan quickly without digging through raw API responses every time. Pricing is where the dashboard becomes operational, not just informative. Anthropic publishes separate pricing columns for base input tokens, 5-minute cache writes, 1-hour cache writes, cache hits and refreshes, and output tokens. On the pricing page, Claude Opus 4.7 and 4.6 show $5 per million input tokens, $6.25 for 5-minute cache writes, $10 for 1-hour cache writes, and just 50 cents for cache hits and refreshes. Sonnet has the same structure at lower rates. That tells you the whole game. Writes cost more than a plain input request, but successful reads are far cheaper. So the question for a team is not just did we enable caching? It is, are we reusing that cached prefix often enough to justify the right cost, and which models or workspaces are paying back the fastest? That is exactly why the screenshot includes both read ratio and write amortization. Anthropic is nudging developers to stop treating caching as a blind checkbox and start treating it like a measurable optimization loop. The official cookbook makes this even more concrete. Anthropic's prompt caching notebook says the feature can reduce latency by more than 2 times and cut costs by up to 90% for repetitive tasks. The example notebook starts with a huge shared context, the full text of Pride and Prejudice, then compares a baseline request, a first cached call that writes the cache, and a second cached call that reads from cache. The code shows the recommended automatic approach at the top level of messages.create, and the helper function prints input tokens, output tokens, cache write tokens, and cache read tokens after each request. That is important because it connects the dashboard back to a real workflow. The dashboard is not inventing new behavior. It is packaging the same usage signals developers already get from the API and cookbook examples. If you run large prompts, long system instructions, tool-heavy flows, or repeated conversations, this kind of observability makes it much easier to spot whether caching is really compounding or whether your prompt structure is leaving savings on the table. So the honest verdict is this. The launch post itself is thin. It gives us one screenshot and no live walkthrough. But the surrounding documentation is strong enough to explain why this dashboard matters. Anthropic now has a public story that ties together cache read ratio, cache writes, cache hits, amortization, TTL strategy, and direct cost trade-offs by model. If you build large context apps on Claude, that is useful immediately. The main limitation is obvious. We still cannot see the full live product flow without signing in. But even from the public sources, this looks like a practical step toward making prompt caching less opaque and much easier to tune in production.